Hi everyone! Today we are going to learn how to identify the reciprocal graphs of trigonometric ratios. I know that sounds like a lot, sounds really complicated, but I assure you it's not. I'm sure you can, but once we're finished with this, you will be fine and you will understand everything that we will be learning today. Okay, so let's start with a quick little do now. Using GeoGebra, graph y equals the sine of x. So please open up GeoGebra, plug that in, take a look at the graph. Okay, now this is actually the graph that we have here. So that's what the y equals sine of x looks like. Again, just a couple of characteristics. Remember that the sine goes through the origin, sine graph goes through the origin, okay? And we have here, this is an example of one full sine curve from 0 to 2 pi. Okay, so right around there would be 2 pi, where it crosses back at the x-axis over here. Now the next thing I want you to do is follow the steps that I have outlined for you so that you can change the x values on the x-axis. What we want to do is change them so that they're in terms of pi. Okay, so the first thing that you're going to do is click on those three horizontal bars at the top left of the screen in GeoGebra. Okay, you're going to click there. You're going to see this open up here. Next thing you're going to do is click on Settings. Okay, then we're going to go click on Distance or Length. And this is going to open up for you. You're going to make sure that this is off. You're going to slide it to the left to turn it off. Here you're going to make sure that the x-axis, you're going to replace whatever number is there. It's probably going to be a 1. Replace it with pi. And we're going to replace this number, if it's something other than 1, replace it with 1. Okay? This means that our y-axis is going to be in a scale of 1, and our x-axis will be on a scale of pi. Okay? All right. So once you have that, let's move on to the next slide. What we want to do, because there's a couple of things we need to know, prior knowledge, before we can really dive in and take a look at these reciprocal graphs. Let's go over what a reciprocal of a trig function is. So the reciprocal of the sine of x, remember that's just taking it and putting it over under 1. So sine of x, the reciprocal of that is 1 over the sine of x. Okay, cosine of x is 1 over the cosine of x. Tangent of x is 1 over the tangent of x. And they have specific names, okay? So the reciprocal of sine of x is cosecant. Cosine, the reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay. Let's take a closer look at just the sine function. Okay, so I have a couple of different degree measures here. You'll see. First thing we're going to look at is the sine of 90 degrees. The sine of 90 degrees is equal to 1. Okay, if you don't remember that from the chart that I encouraged you guys to memorize, plug it into the calculator and you'll know that the sine of 90 degrees is equal to 1. All right, so now in terms of its reciprocal, 1 over the sine of 90 degrees is going to be 1 over 1, and that equals 1. So therefore, cosecant of 90 degrees is also going to be 1. Okay, in this case, the sine and the cosecant, both the sine itself and its reciprocal are going to be the same thing. Let's take a look at 180 degrees. The sine of 180 is equal to 0. Okay, now in this case, 1 over the sine of 180 is going to be 1 over 0. Remember, we cannot have 0 in the denominator, so that's going to be undefined. So, cosecant of 180 degrees is undefined. Okay. What are some things we notice about the graph of y equals the sine of x? So just some characteristics you want to be able to identify Because if you're given a graph, you want to be able to say, okay, well, that's, you want to be able to decipher the difference between the graph of the sine function, cosine function, tangent. Tangent's the easiest. You'll see that in a few minutes. Cosine and sine sometimes are a little bit, I guess, harder to tell the difference between. But sine, remember, the sine of 0 is 0. So it's going to go through the origin, okay? And again, like we just saw, the sine of 90 was 1, okay, which would be here. Okay, at that point, that would be pi over 2. You've got pi there, and you've got 2 pi. Remember, pi is the same as 180. 2 pi is the same as 360. Remember now, how do we know that? That's from converting degrees to radians. Okay, so for example, 90 degrees, I know that that's pi over 2, because if I were to take 90 and multiply it by pi over 180, I'm going to get pi over 2, which is here. All right. Okay. So that's one thing, one of the characteristics. Again, we're going from negative 2 pi to positive 2 pi, and you can see on the graph where sine of 180 is 0. Okay, sine of 360 is 0. Sine of 270, which is going to be here, okay, that would be 3 pi over 2. Okay, and that's 270. That would be negative 1. And if you're not sure, you can just plug these into your calculator and get the values. Okay. Now let's take a look at, it's the same sine function, but now not only do we have the sine, we also have cosecant on the same graph. Okay. What do you notice here? How is it similar? How is it different from the sine function? Do they have any points in common? Do they have no points in common? First thing I would say that I notice right off the bat is the sine function is a continuous curve up and down, okay? However, cosecant is not. It looks like we have 4 separate graphs just from negative 2 pi to positive 2 pi. We see 4 separate graphs. If we were to expand this out further and not put limits on the x-axis, you'd see more going in either direction. Why do you think that is? Okay, so you see the little question here in the little pink cloud. What is an asymptote? Remember back when we talked about exponential functions and how they have a certain limit or a line that they, almost like an invisible line that they approach but never ever cross. They'll never intersect that line. They will spend infinity approaching it and coming really, really, really close, but they'll never cross it. That's an asymptote, okay? Now, think back to 2 slides ago where we talked about parts of the reciprocal that were undefined, okay? The sine of 180 degrees, remember that the sine of 180 is equal to 0. And because of that, the cosecant of 180 is undefined. Okay, that means that there is no point at 180 degrees. And remember, 180 degrees is pi. Okay, that means pi on the chart, on the graph. So we go over here. We don't have a point. We have a point here for sine, right? Sine of 180 is 0. But we don't have a point on the cosecant graph because it's undefined at that point. That's, and if you look, we can draw this imaginary line. That is our asymptote. Okay, because these two, the graph will forever approach this line, which is x equals pi. Remember, it's a vertical line, so it's x equals, in the form of x equals. It will always approach that line but it will never intersect it, okay? And do you notice any more asymptotes in the graph? We do have a few more. We have one, actually the y-axis, okay? X equals 0, that's the equation of that, x equals 0. We have another one here, x equals negative pi. Oops. Let me lock that. Okay. X equals negative pi. We have another one over here at x equals negative 2 pi. And we have another one over here at x equals positive 2 pi. So these are all the vertical asymptotes that we have for cosecant of x. Okay. All right, so now we're going to do the same thing for cosine. Cosine of 90 degrees is equal to 0. Therefore, 1 over cosine of 90 degrees, same as 1 over 0, undefined. So secant of 90 is going to be undefined. What do you think we're going to have then at that point? We're going to have an asymptote. Cosine of 180 degrees is equal to negative 1. So 1 over cosine of 180 is equal to 1 over negative 1, which simplifies to negative 1. So the cosecant of 180 degrees is negative 1. Okay, a couple of things we want to identify about a cosine function. Notice that since the cosine of 0 degrees is equal to 1, that's where it's going to intersect the graph. Okay, cosine of 90, which is going to be here because that's going to be pi over 2, is 0. Cosine of 180, which is pi, is going to be negative 1. Okay. Cosine of 270, 0 again. Cosine of 360, which is 2 pi, going back to 1. Okay. Now let's take a look at cosine as well as its reciprocal. Okay, so what do we notice here? Kind of looks very similar to cosecant. Okay, we've got now here going from 2 pi to negative 2 pi, we have 3 full graphs and 2 half graphs. They almost look like parabolas. Okay, and again, where cosine is equal to 0, that's where you find the asymptotes for the reciprocal. Because wherever cosine is going to be 0, the reciprocal is going to be undefined. Okay? So let's just write that down on the side here. Where cosine is 0, where cosine equals 0, secant is undefined. Okay, so looking here, we've got asymptotes here, here, over here, and over here. Remember they're vertical lines, so they follow the form of x equals. Okay, we got x equals negative 3 pi over 2. X equals negative pi over 2. X equals pi over 2. And x equals 3 pi over 2. Okay. All right, now let's take a look at tangent. So tangent of 0, if tangent of 0 equals 0, then 1 over the tangent of 0 is going to be 1 over 0, which is undefined. Therefore, cotangent of 0 is undefined. If the tangent of 45 degrees is 1, then we're going to get 1 over 1, which equals 1. Cotangent of 45 equals 1. So looking now, when we go on to the graph, remember that tangent, okay, tangent is equal to sine over cosine. Because of this, we know that there are certain degrees where cosine is 0, which means we're going to have parts of the tangent graphs that are also going to be undefined, okay, because of that. So this is what y equals tangent of x looks like when we graph it, okay? Very different from sine and cosine because we don't have a continuous graph. We have what looks like this because we have those asymptotes. So the regular tangent of x has asymptotes all of its own, okay? And again, it's where the tangent's going to be undefined, okay? And that's going to be where cosine is equal to 0, okay? So wherever cosine is 0, you're going to get the tangent to be undefined. Okay, so looking at this, you can tell that you're going to have an asymptote here. You're going to have one here. We're going to have one over here. I'm trying to draw this best I could. It's got to get closer. Okay, and another one over here. All right. So again, remember, it's where cosine is equal to 0. So this is going to be negative 3 pi over 2. Okay. Negative pi over 2. Pi over 2. And 3 pi over 2. Okay, notice it's going to have the same as what we had up here. Okay, because that's where x is equal to 0 for cosine. Okay, so now looking at the reciprocal, it's the same graph, just it looks like it's going the other way. Okay, it's reversed. This time, notice that let me see if I can get this out a little bit here. Notice that this time the cotangent is actually intersecting the tangent, the asymptote where the tangent is actually, like in this case, negative 3 pi over 2, that's what it's going through. Negative pi over 2, and 3 pi over 2. Okay, so here we have that, and the asymptotes then are going to be different. So the asymptotes for, let me get this here, the asymptotes for cotangent are going to be different. They're not going to be the same as the asymptotes for tangent. It's actually, in this case, it's going to be where sine is equal to 0. Okay, because now cotangent, is that right? Did I missed this one. This is, sorry guys, this one I messed up. Should be here. And we have one here too. And I messed this one up. Sorry guys, it is late and my eyes are starting to play tricks on me. There's one. Am I missing another one? Did I intersect this one too? I'm starting to go crazy, guys. Purple lines. That one. Hold on a second. I am going crazy. Oops. What did I do? Okay. Hold on a second here. All right, so here we go. And we have one here. And we have one here. There we go. Okay, so these asymptotes for cotangent are going to be the same where sine is equal to 0, because remember, cotangent is now the same thing as cosine over sine. So wherever sine is going to be equal to 0, that's going to give you the cotangent where it's undefined. Okay. So the next thing you're going to do is identify the graphs displayed as the sine and secant, cosine and cosecant, or tangent and cotangent. Okay. So let's take a look here. For the first one, that should be easy. We've got tangent of x and cotangent of x. For the middle one, what do we have there? Notice I can tell that the where x equals 0, y is 1. That tells me that I have cosine of x and secant of x. Okay, and the last but not least, we have the sine curve, sine of x and cosecant of x. Okay. State the vertical asymptote for each graph. So you want to state all of them from negative pi to positive 2 pi. Okay, here we have, start with negative 2 pi, negative pi, 0, pi, and 2 pi. So asymptotes are going to be x equals negative 2 pi, x equals negative pi, x equals 0, x equals pi, and x equals 2 pi. Okay, state the vertical asymptote. So again, we're going to draw the asymptotes here. Okay, and here we have asymptotes. X equals negative 3 pi over 2. X equals negative pi over 2. X equals pi over 2. X equals 3 pi over 2. Okay. Let's take a look here at the next one. Okay, asymptotes. X equals negative 2 pi. X equals negative pi. X equals 0. X equals pi. X equals 2 pi. Okay. So for the sum it up, what is an asymptote? An asymptote is the line that the graph will be approaching. However, it will never intersect it because at that point the graph will be undefined. Describe the graph of the cosecant of x. What is the asymptote? So let's take a look. Which one is that one? Can we tell what that is? That is the cosecant of x. Okay, let me write over here. Y equals cosecant of x. How do we know that? Take a look at the one of the asymptotes, x equals 0. The sine of 0 is 0. So because of that, this is undefined. That's why there's an asymptote going through x equals 0. So that's how we know. Okay. Scrolling back up just to really quickly. Here we know that this is reciprocal of cosine, so y equals secant of x. And then this one is y equals cotangent of x. Notice the asymptotes here are the same as the asymptotes here for secant, for cosecant. And remember that's because when cotangent, your denominator is sine. So wherever those are, wherever sine is equal to 0, those are going to be undefined. Describe the graph, and we did, what is this? Asymptotes, we did that. Does the asymptote change if the equation is y equals 2 times the cosecant of x? What I want you to do is plug this into GeoGebra, and I want you to tell me if the asymptotes change. If they don't, or if they do, please tell me why, and just briefly describe that graph and see what it looks like. Okay? I hope you found this helpful, guys. You know how to reach me if you need any extra help. You can always message me on Hangouts, Remind, or send me an email. All right. Bye, guys, and have a good day.